Good evening, everyone, and welcome to the November Rocky Mountain Railroad Club meeting. It's just 7:30 now, so we should get this on the road. Our guest speaker tonight is Ed Dickens from the UP STEAM program, and oops. I just committed my own sin. I forgot to mute the YouTube stream. First, I'm going to hand it over to our Vice President, Dave Schaaf, for club news, club notes, a few things about the December annual business meeting that we all should be aware of. So, okay, Dave, you should be able to unmute yourself now.
Okay. Hopefully you guys can hear me. I'm hosting this, my part of the hosting from my home computer today. And it's kind of got low horsepower, so that's why I've turned off my camera, because it doesn't seem to let me do picture and sound at the same time. Hopefully you can hear me. Typically, Denny Leonard, our president, and I, who I'm the current vice president, we usually host this from his place of business with a larger screen, computer and camera and all that stuff. Didn't work out this time. Denny's feeling a little bit under the weather, so Nathan and I are taking this on. We're both past presidents, and yeah, as he said, our next meeting in December will also be our annual business meeting. So those of you that are members, we will hope that you will call in or tune in via the Zoom meeting, and we'll try and figure out the feature that lets people vote. I mean, we have the formalities of the usual annual election of officers and half the board of directors. Nothing terribly complicated. We've all done this before, and the instructions and minutes will be in your newsletter coming out for December. Also, yeah, Nathan has already said that Ed will be our presenter. I guess I don't really have a whole lot else to say before we get to the program. I think Ed is going to be able to take some questions at the end of the program, and we're all dealing with the challenges of our technology. So it's not the ideal way that we would like to do a meeting, but we're doing the best we can. And if Ed ends up having to turn off his picture to make his audio work better, you'll maybe understand why. So Nathan, if you will let Ed in verbally, we'll let him start.
Sure. Dave, did you want to mention what the December program is going to be?
Sure, I can mention that at the end too, but yeah, our guest presenter for December will be Scott Lotus from the Center for Railroad Photography and Art. He will have I don't have the exact details of the program with me in front of me right now, but they have access to such good content that I can guarantee it's going to be a good program. He was also a presenter for us at one of the club's annual banquets several years ago. And coming up in January, the presenter will be Steve Berry from Railfan Magazine. He will be giving us an update with some pictures on what's been happening at the East Broad Top. They are making an amazing comeback in just the last few months. And I think he will also have some really recent pictures of a former Colorado steam locomotive, Great Western number 90, running at the Strasburg. And then our presenter for February will be Stephen Peck with some of his pictures from some of the many places he's been in the railroading industry and tourist world over the last several years. So I will mention this again at the end, but yeah, let's go ahead and let Ed do his thing.
Okay, thanks, Dave. Just a couple of notes first. I'd ask everyone, we'll do this like we do usually. We'll keep everybody muted through the main presentation, and then toward the end, we'll do sort of a question and answer for those of you on the Zoom call. I'd ask that when you're not asking a question, you keep yourself muted just to keep the amount of noise on the call down. The other thing is, please remember that Ed is still an active UP employee, so there may be some things that he just can't comment on just because that's the nature of the job. So please understand if he just says, I can't really talk about that right now. That's just the constraints of working for a large corporation in this day and age. So with that, let's see, Ed, unmute you. And all right, there you go. You should be active. Can you? Yep, we can hear you. Perfect.
All right, very good. Well, hello everybody, and I want to thank everyone for inviting us on this presentation tonight. Regrettably, I'm here alone, so the staff can't be here with me like we like to have them accompany me when we attend these presentations. So I've got a little bit of technology challenge here. So we've got some photographs and some video that we're going to share with you. So we're just going to talk about a lot of the stuff that we've done last year. As everyone can remember, one of the favorite things I like to ask people is, did you really think, how many people thought that they would ever see a big boy steam locomotive operating? That's a really fun way to open up any presentation when you're talking about something as significant as a big boy steam locomotive running. As many people know the story, and I'll just summarize it really quickly, it was something that just kind of fell into my lap as the person in charge of the steam program. The opportunity to restore a 4000 class locomotive was something that I think many people dreamed about. A lot of people asked about that over the years, and many people speculated on why it would or could or should or shouldn't ever run again. So we spent quite a lot of time getting our shop in order, fixing the 844, doing the things that we needed to do to that locomotive. And before we could really jump in on the big boy, we had a very critical timeline ahead of us, as everyone remembers. And I just lost my video feed there, but and excuse me, I'm on my cell phone. There we go. There we go. Does everybody have me again? I apologize for that. This is probably one of many little technical glitches we'll encounter tonight. Can everybody see me okay? There we go.
Yeah. Yes, you're back.
Okay, I'm back. I can't see myself, but that's okay. All right. Can everybody hear me okay? I apologize for that. I've got 2 cell phones and an iPad going here, so we're just trying to keep our technology alive long enough to get through this presentation. So, will Dave help me out, or Nathan? Are we looking at the first series of pictures that I sent you?
We can in just a second.
Okay. Well, I'll just kind of keep talking through that, and you can work through showing some of those photographs that I sent you. As people remember from the earlier presentations that we've given about the steam locomotive, that our intention was from the beginning to completely rebuild the locomotive necessary for 30 plus years of serviceability for the Union Pacific. The same strategy was true with the 844, to do what we can to keep this equipment running. Like any big locomotive, imagine how old the machinery is. The locomotive itself, the boiler, various running gear components, and just every aspect of that locomotive. Back when they ran the 4000s, the 4014 was one of 25. So there was nothing necessarily special about it back when it was a utilitarian tool. When we returned the locomotive to Cheyenne, it was our intention that it was going to continue to be a tool, but no longer really a utilitarian locomotive that it was designed to be, in the sense that it was pulling freight. So we've made numerous modifications to it to make it easier on us. And so we've integrated a lot of those upgrades into the final result of what you've seen. With any locomotive, with any big rebuild, there's a certain degree of uncertainty when you get into anything, whether you're restoring an automobile or an aircraft or even something not quite as big and complicated as a locomotive. there is a degree of uncertainty that what you will be revealed when you get the locomotive disassembled. And so you've got to factor that into your timeline of being able to get the entire project completed in time. So what that translates to is going to be a lot of hard work ahead of you. Just getting all the materials delivered on time. The timing of a lot of these big components is in itself something that can take a year or more. So back when we were doing the work on the 844, every opportunity that we had, we were working to make sure that we were getting all the materials in the pipeline to be delivered, hopefully when we needed them to get the big boy together again. You've got a big giant boiler on this big steam locomotive, and it's not much of an exaggeration when we talk about the size of the big boy and comparing it to the 844. When that boiler, that firebox, must deliver sufficient steam to not only 2 but 4 cylinders, just a little bit smaller than the cylinders on the 844. It gives you a sense of just how big that boiler really is. So we've had all that work cut out for us to get that locomotive assembled and get it back together again. The plan, my plan, was to have a really good opportunity to take our time and break that locomotive in. You factor that into the overall project timeline that we want, in my mind, just kind of an arbitrary number of 500 miles that I would be able to operate the locomotive, take our time, and break in all those components. As everyone recalls from a time a little over a year ago, year and a half now, we only had one day that we could break that locomotive in. And that's the night that we took the locomotive down. We were going to try to make it all the way to Greeley, and we made it as far as Nunn before it just got too late on us. But fortunately, we've got good technology, a good design, and that was what's true with all big modern steam locomotives. They're good technology. They're very well designed, very well engineered. The UP 4000s, 3900s, 800s, and even some of the smaller, earlier class locomotives were such a very well-designed locomotive that if they were assembled correctly and all the clearances were correct and the locomotive was cared for, lubricated, that you were going to have a good locomotive on your hands. It was a little bit worrisome, as you can imagine, because in my mind, I had every intention of running that locomotive at least easily a month, 500 miles, taking our time, making adjustments as we go. Well, I'm going to skip ahead now and tell you about what it was like when we departed with the doubleheader going to Ogden. And we had planned just a once-in-a-lifetime event with our senior executives. And they had invited lots of dignitaries and members of the public to participate in what we called our christening ceremony. And that was to happen in Cheyenne, just right across from the steam shop. Bear in mind that this was 30 some hours from the time that we first moved that locomotive. So tensions were a little bit high, but we were confident that what we had was a very good locomotive. Even though we only had 2.5 years and we did a very, very thorough job, 2.5 years is an accelerated timeline from what my original intention was. So when we operated that locomotive, I think sitting on the edge of your seat kind of sums up the feeling that we all felt. Everyone plays such an important role on the crew, and all the work that everyone did. Everyone worked just unbelievably hard. When you consider all of the different complex components and all the different phases of the locomotive, we frequently had our executive colleagues come out to the shop to check on us and just to see if there was anything that they could do to help support us. And I remember on several occasions, they would ask me, you can see the smile on my face, they would ask me, Ed, I don't know much about steam locomotives, but I see these parts on the floor, and they're pretty big parts. And again, I don't know much about steam locomotives, but they're big enough parts. Are they supposed to be on the engine? And how long is it going to take to get these parts on the locomotive? So there was all that tension and everything culminated in just a remarkably enjoyable period of time once everyone could start to relax once we got the locomotive delivered. As we left Cheyenne that morning, we had our executives in the cab with us. And that was a very, just a real surreal moment. We departed up 3-track, heading up Sherman Hill. And here's this historical moment where we have a current president of the Union Pacific, a past president of the Union Pacific, and another past president back riding the train, and other guests in the cab with us. So combining that historical moment with the fact that we've got this new locomotive that I'm still going to break in on the way, all the way to Ogden, was something that I'm never going to forget. So I'm going to jump ahead real quick and talk about some of the things that we experienced on the way to Ogden. The locomotive performed, I will say, flawlessly. We had the 844 with us. We also had a diesel locomotive with us. And I'm going to talk a little bit about the strategy of a diesel locomotive, because that is a very frequently asked question. And I think it deserves a pretty thorough explanation. So toward the end of the presentation, Nathan, if I get sidetracked and I don't get on that subject, please remind me, because I would like to just talk about that a little bit. So,
absolutely.
Yep. So as we're going to Ogden, we've got the 844 tucked in behind us. Now, the 844, when you double head, it's pretty commonly understood that the little engine is up front. I never thought I would say or refer to the 844 as a little engine, but in this instance, it's a little engine. Well, our intention was we wanted the 4014 in the front. It was the significance of having the 4014 restored and operating. So that was one of the few times in the 844's existence that it, and I don't want to say it played second fiddle, because it does not, but it was tucked in behind us with Ted and Kurt back there. So here we are gallivanting up our way up 3-track, going up to Sherman Hill. And we've got new valves, new pistons, all new piston rings, new valve rings, bushings, and I could just enumerate all of the new components that we've put on this locomotive, painstakingly assembled by hand, designed by us, in many instances machined by us. Most of the big heavy-duty components, we put everything on the locomotive. Some of the big stuff we outsource, some of the machining, the crossheads, for example, and a few things like that. But other than that, we did all of the work, 100% of it in the shop in Cheyenne. So we had confidence that it was going to work well, because when we assembled everything, we're just very thorough in the assembly process. But there's a lot of different sights, a lot of different sounds, and a lot of different sensations, and most importantly, a lot of different smells that you have with a steam locomotive. Not only are all the machinery components new and the lubrication is being delivered at a higher rate than it normally would be because it's a new component, you have all the different smells of the paint and the insulation and every other little component and the different types of paint. So you're just being overwhelmed with what could be running hot, because you're smelling a tremendous amount of heat coming off of this big machine. So you're definitely on the edge of your seat. But once we get up and we get about 30 or 40 miles, you start to kind of relax just enough to kind of take in some of that scenery and enjoy the moment. I'll never forget our chairman asked me, and when things calmed down a little bit and we got off up beyond Spear and we were a little bit away from roads and other things, he came over and he asked me, he goes, well, how's everything going? And we were running right about 30 miles an hour. I had kind of this self-imposed speed restriction of no more than 30 until I got a little bit more mileage under the locomotive. And I commented to him and I started to show him the speedometer and point out a few things. And he was so overjoyed. I'll never forget the time that we spent in the cab together, and he continued to congratulate us. And he had that smile on his face the entire time. So as we continued to work our way up to Laramie, we dropped them off at Harriman, we dropped them off at Laramie, serviced at Medicine Bow, overnighted at Rawlins, and then we kind of got into a really good routine from that point on. Worked our way up the next day, made our way to Rock Springs, then again to Evanston, and then we had a little bit of gyrations in Ogden to get the equipment turned around. And this particular event in Ogden was going to be very special, and it's one that we put together many months ahead of time. And we wanted to figure the best way, what is going to be the best way to really make this presentation of the equipment. We're going to have the 844 with us facing in one direction and the 4014 in the other. But we had to turn those two locomotives. And I'll remember the superintendent in Salt Lake in Ogden, he had an idea that we were going to turn the locomotives such that we would need to use both main lines. And using both main lines on the transcontinental, it's a good thing that he was with me, and it was his idea to use both main lines. So we positioned both of those locomotives next to each other, one of them on track 1, one of them on track 2. And it was a very rare photograph. Dave, I believe I sent that to you. I hope that you're able to put that photograph up, because it's an extremely rare shot. There was virtually nobody there, so we were the only ones that were there to capture that moment. But that was a very special event for us. When we, I'll never forget, over the time in my career on the railroad, I'm very nostalgic about certain things and about events and about people, about occurrences, even the clothes that we wear. So we had all decided that we were going to dress alike. We're going to have the same type of blue denim shirt. At the last moment, I was given a red neckerchief from a good friend of mine, Brian Stone, a manager in Evanston. And so I had that red neckerchief around my neck, a baseball cap with the 4014 logo. And we had arranged that our CEO was going to communicate with us by radio. And as I mentioned, months prior to that, we were talking about how we could really make this event special. And I love railroading. I've always loved railroading, and I'm a railroader. And many in the planning organization have different backgrounds. So I made the suggestion that why don't we get one of the maintenance away vehicles, and they've got large speakers on their trucks, and we can communicate, and we have that maintenance away vehicle standing by where everyone can hear the audio. And that's how that whole presentation kind of morphed into what everyone witnessed. The language that we used, the railroad language. It's not often that you can witness a CEO of the Union Pacific speaking to a locomotive engineer and using the correct language, the correct radio brevity, all of the right vernacular that we use, that we speak as railroaders. There's a little bit of a slang, and there's almost a proud way that you speak using the slang language. It's formal, it's professional, but take them ahead. 4014, bring them ahead. 4014, start them back. All that neat language. So it was really a special time for all of us. I'll never forget also that morning, Mr. Fritz was being readied for a media interview, and they had asked me to come speak to one of the local TV stations there in Ogden. And as I walked up on stage, I'll never forget, Mr. Fritz said to me, "Is that Ed Dickens? I want to be Ed Dickens." And the sense of pride that we all had, and just making him proud, was something that it made that whole event. I get goosebumps telling you about it now, but it was remarkable. Well, now I want to go back and talk about, we made the trip home with no incident. We had a minor derailment at Rawlins. Most people probably know all about that one. It was really, I don't want to say it's a non-event. Anytime a 4,000 class locomotive leaves the rails, that is certainly not a non-event. But as derailments go, it was pretty minor. I want to talk about what we did on the rest of the travels and how remarkable the crew performed, and how all of the due diligence and the workmanship and everything that everyone put into the locomotive paid us dividends as we began to travel just under 9,000 miles. A big boy locomotive, as everyone knows by now, they were designed to operate on the Union Pacific Railroad pretty much in a confined region, Ogden, Green River. It was later expanded. They were seen in Denver, operated to North Platte every now and then. They were cleared in other parts of the system. Our intention is, it was, and it is still, that we're going to travel everywhere that we feel there is a public relations benefit to take the locomotive. So this travel last year saw us in places that, on railroads that really, I don't want to really characterize them as that they were not designed for a 4,000, only because most other railroads did not have locomotives of that size. So the Chicago Northwestern, Southern Pacific Territories, some of the Texas railroads that we traveled on, they have all been upgraded over the years, through a period through the 1970s into the 1980s, and then post-merger upgrades have occurred on all those lines. So an engineering analysis is conducted officially, and then a second one is conducted by me personally by traveling in the field to confirm that we will be able to take the locomotive everywhere it goes. That is one of the interesting parts, and one of the more enjoyable aspects of my job is doing all of the behind the scenes engineering, all of that analysis, measuring curves by hand, not leaving any stone unturned, because I've learned, and I know in the time that I've been operating large steam locomotives, that you get one chance to plan a steam trip, and getting the locomotive into a situation, and I'll use the Rollins derailment as an example. That is an unacceptable boo-boo. And that is something that we cannot experience network impacts. So the planning has to be extremely thorough, and we cannot leave anything to chance. So those are the things that are important when we begin to analyze everything. And that's and just a quick segue into why it takes a long time to release schedules when we're planning a trip. Oftentimes, our vision going forward is that we have all of the planning and all the analysis conducted well in advance. So we release that information to the public in a very timely manner. We were stuck with a few challenges last year, and that impacted why it took so long to get that done. So when you're thinking about such a big locomotive, you've got the swing out, the way the locomotive articulates, that big, long, rigid boiler, and it is protruding in a straight line outward if you can think about the locomotive in a curve. There are many videos, many good photographs on the internet that talk about and illustrate the articulation on a big boy. And that illustrates the need for that thorough planning that we do. That's one of the interesting things when you're operating that locomotive. And the same sensation was true when I operated the 3985. You can feel that front engine. You feel it for those fortunate and lucky to be able to operate articulated locomotives, and there's a few out there. But when they get big like the big boy, the front engine itself, the boiler, everything, it's such a tremendous, immense amount of weight and power that you can feel that. One single throttle controls all 4 cylinders, and you can feel the front engine. When it goes into a curve, there's a feel that you get. The same is true on a non-articulated engine such as the 844. I've operated that locomotive so much that I'm just so comfortable negotiating a what we would call tight curvature. When we have to turn the locomotive, for example, you may get into a 12 or 13 degree curve, 14, maybe even 15 degrees. That's kind of the upper limit with the 844. On the big boy, you've got a little bit more than that. But as you've got that locomotive into the curvature, that rigid wheelbase is placing a tremendous strain on the track structure. The track structure is well engineered and it can take a lot, but it's not really, I don't want to say it's not designed, but I think maybe the right way to look at it, it's not really intended that it's going to be withstanding so much lateral force of having an articulated steam locomotive. So you've got the lateral motion, the centering device springs, all of those things are placing just a tremendous lateral load on the rail. And you could feel all of that. You can actually, there's a sensation that you're feeling in the seat of your pants, in your arm that's reaching up on the throttle, and the arm that's resting on the armrest, because you're leaning out and you're observing this big machine going into that curvature. Well, I want to know before I even get there, I'm very comfortable with everything that lies ahead of me. There's a few places that I don't want to say maybe a question mark, but I know we can negotiate those, but I'm going to be uncomfortable with them until we get through them. And one comes to mind, we called that Nightmare Junction. It's really not that big of a deal. It's only a 13-degree curve, but that was the LST&T junction, what's known as the Winter Street crossing there in Duluth. A few other little places like that. But that's just a magnificent design that Union Pacific, an American locomotive company, designed with the big boy locomotive. And it was designed to operate like that. The movie The Last of the Giants, that great production the Union Pacific put together in the 50s, it illustrates various views of the articulation of the big boys negotiating in the yard in Cheyenne, negotiating switches. And that's one of the remarkable things that you never get tired of looking at that locomotive and feeling it, operating it, firing it. It steams remarkably well. I'll give all of our viewers here on this presentation, that will be one of the next updates that we're working on, is we'll talk about the oil conversion, what our engineering analysis was, our thoughts, why we designed it the way we did, and the improvements that we made on what the Union Pacific would have done had they intended to make the 4000 class a successful oil burning locomotive. So that's kind of, that will be coming up in the coming weeks. You'll see that update released. But back to our travels and back to the big boy locomotive. I think now's a good time to talk about the diesel and why we have a diesel locomotive with us. So we travel with the 844 frequently without a diesel. We've traveled with the 3985 without a diesel locomotive. And when we operate the 4014 with the diesel locomotive, I can assure you that many times, I almost said 90%, but I don't know an accurate percentage, but a very large percentage of the time, the diesel is not producing traction. We just don't need it. We don't need it. Oftentimes, it's an inconvenience to use it. We don't have an MU controller in the cab. We probably will develop one if we could integrate a dynamic brake into that control. For those of you that don't know what I mean when I say an MU controller, MU is the railroad acronym for multiple unit, and that allows us to couple to a locomotive consist, in this case, one extra locomotive, a diesel. And we MU it through the air brake functions. So all of the air brake functions on the steam locomotive are compatible with and duplicated in that trailing locomotive. We can go one step further and create an electrical jumper, and it's the same MU cable that exists between two locomotives. When you see a locomotive consist, you see that. Well, an MU controller allows us to duplicate those electrical functions that you need to control the diesel locomotive in power. We've opted to not use that on the big boy, mainly because of timing and also for convenience. From a safety standpoint, you need to have an engineer in that locomotive. You've got an electrical, a diesel electric locomotive that's computerized. Everybody, I'm sure, can appreciate the potential for malfunction. We've experienced that. And therefore, we have to have, and we always will have, an engineer occupying that trailing locomotive cab. So it's just easy enough to call on the radio and provide him the instructions you need. You tell him the throttle position you want. So now let's get back to talking about why we want a diesel with a big boy. There's going to be times we'll operate without one. But I can tell you from past experience with the 844, most importantly, the 3985 and the 4014, the big articulated steam locomotive, it's a big articulated steam locomotive. The Challenger is significantly smaller. The big boy, it's a big machine, no pun intended. So what happens in the morning, typically in the days of steam operation, the locomotive would come off the coal chute. The locomotive would run light power with the engineer and fireman and the brakeman, and they would work that locomotive off the fuel track, if you will, the service track, and it would work its way over to the yard lead and negotiate through a number of switches, negotiate yard trackage coupled to its train. And in the process of doing that, you've got ample opportunity to work a tremendous amount of condensation out of the system. Cylinder cocks are open. It's a light locomotive. You operate the throttle accordingly. It doesn't take a tremendous amount of tractive force to move a light locomotive. When you're talking about a steam locomotive, the 4000, and it's coupled to a large train, and you're leaving in the morning from a display location, we have to jump start, literally, right out from a dead stop and begin moving the train. If we didn't have the diesel locomotive, there is many times when there is just an opportunity for something to happen. And when I say something, I'm talking about water in the cylinders, water in the superheater. It's harder to handle a locomotive carefully in the morning when starting fresh, starting completely cold, even though the boiler's up to full pressure. The superheat temperature itself is not up to full superheat pressure or temperature. And therefore, you've got a tremendous amount of condensate. So, well, let me just preface the further explanation here and beg your indulgence for more technical talk. For those that are into steam locomotives, you're probably following along. But suffice it to say that when the locomotive is, when we leave any place, oftentimes we have to leave uphill. And I learned early on how much I was happy that we had that diesel back there. And the reason we're happy, it's very simple. It says Union Pacific on the side of that tender, but that locomotive is ours. Every one of us that put our hearts and souls and so much time and effort into that locomotive, it is very much our locomotive. We are entrusted with that responsibility. Therefore, we're very careful with it. We want that locomotive to be around for years. I try not to slip the drivers because they're my tires. I'm responsible for them. I got to pay to fix them. So prolonged slipping and continual slipping and all those things, it continues to accelerate their wear. So hopefully I've explained that in a way that kind of makes sense to people. When we leave in the morning, once we get to the locomotive, you may operate 1,000 feet. Sometimes it takes a little longer than that to get that condensation out of what we call the channel drains and the steam chests. All those big horizontal steam lines on an articulated locomotive. Next time you take a look at a picture, a photograph of the 4014 or any big articulated, particularly the 4000s, notice those big, long, they're 8-inch diameter horizontal steam pipes that run from the smoke box, the superheater header. One line runs up to the front engine, another line runs back to the rear engine. Imagine how many gallons of condensed steam, liquid water, is present in that system. Because of that, next time you look at a picture, notice that the 4000 and the Challenger as well has 6, count them, 6 cylinder cocks. You've got the traditional cylinder cock, one on each end of the cylinder, and then you have one in the center. The center is referred to as a channel drain. And that's, as the name implies, it's designed to take and allow that large volume of condensation and eliminate it out that center cylinder cock, or the channel drain as we call it. So even though you've got all that special technology and the additional cylinder cock channel drain down in there, you still have a tremendous amount of water. We've cleaned the locomotive from the night before. We've got grease here, we've got oil there, we've got mineral spirits. So on top of all that, you've got to start. You've got to lift a heavy train with effectively cold cylinders. So that's one of the bigger reasons we have a diesel locomotive with us. And I'll just wrap it up here in the next couple minutes and give you additional explanation about our fuel and our water logistics. Last year when we operated, I was only able to estimate and guess what our fuel consumption would be. We can estimate. When we first began exploring a 4000, I felt it was prudent to just make the assumption that we would consume double fuel and water. The Challenger is 35 to 40 gallons of fuel per mile. The big boy burns 25. So it's much more efficient, but that's a function of new rings, new valves, tight boiler. So even at that, with the 25 gallons of oil per mile consumption, you can do the math and figure out what your range will end up being. So with that in mind, having a diesel there, should we encounter any type of delay along the way, that's going to help us to reduce the load on the locomotive and therefore reduce our fuel and water consumption. And then we'll be able to make our objective for the day, the end of our travels for the day, and avoid the most unforgivable sin of all Class 1 steam operations, and that is avoiding network impact. And that is one of our main priorities. And as we plan, very carefully plan and analyze any potential problem that we might have, we must engineer a solution away from avoiding those network impacts. So with that, I think Dave and Nathan, I think we can open up to questions, unless you guys have any questions to kind of start the questions off with. But I hope that explanation on the diesel locomotive was not too technical. And forgive me if it's a little bit on the technical side. We live in the technical steam locomotive world, and I know there's a lot of people out there that live there with us, and they're able to follow along in the technical. But occasionally there's some novices and some new enthusiasts out there, and we want to be able to speak in a way that they can understand it too.
All right, then. Hold on just a sec. I will open up. Okay. I've allowed you to unmute yourselves. If you'd please unmute yourself, ask your question, and go back on mute and allow our host or our guest tonight to answer, that'd be appreciated.
Good. Ron Kaiser. Hi. How are you?
Hey. Hi, Ron. Good to hear your voice. How are you?
Good. I remember our days on the Georgetown Loop.
I do too.
how much fun we had, but I also remember being impressed with your knowledge of not only steam engines, of course, but physics and metallurgy. That you had more knowledge of those two sciences than most other people I've worked with. And I thought at the time, you're going to go places, what you have. But, I enjoyed our time together on the loop. And for a year or two in Durango. Good to see you again.
Good to see you too, Ron, and thank you very much. If I could just share a quick story about that. Ron, do you remember the day that we were operating the 14 And we came around the corner just around from the mine stop. I forget the name we called that bridge. And there was a deer on the track, and
Yeah.
she had her little baby fawn.
Uh-huh.
And we came around the corner, and the deer moved out of the way, and there was that little baby fawn there. And so I started blowing the whistle, and it looked like we were going to hit the fawn. So I went ahead and stopped. And on a 4% grade, that's pretty easy to do with the Shea locomotive. And we had just barely nudged that little fawn. It was just frozen in the track. It didn't move, and we knocked it over. And I remember, I thought, oh my goodness, we ran over this beautiful little animal. And I went up there in the front of the engine, and it was laying right underneath the pilot deck. Do you remember that?
Yes, I do. Yeah.
Yeah.
I thought we had deer meat for dinner, but yeah,
Yep.
that was. And the fact that we didn't kill him was amazing too.
Yeah, we didn't harm it at all. I picked it up, and I didn't know what to do with it, and we carried it off into the bushes, and there we were. But yeah, that was a fun day. The Georgetown Loop was just a wonderful railroad.
We never saw him again. He took off, and Mom saved him or something. But yeah, that was great. I remember that. Yes.
Yeah, the Georgetown Loop was just a great learning experience. It's a great railroad, 4% grades, steam locomotive, Shays, the 40. It's just a very well-kept locomotive, well-kept cars, well-kept track. I really enjoyed my time up there.
We got our whiskers there, huh?
Absolutely. Yeah. Hugo Lackman, Neil Vodden, guys that the true steam men of the 1940s era, working with them and hearing their stories, and
remember
they were
our brakeman Sue.
Yes, absolutely. Yes, I do.
Who was not like an average female brakeman. She knew her stuff. She was good. Yeah.
She was. Everyone there was just so talented, skilled, passionate, professional. What a great place to work.
It's fun working with you. I enjoyed it.
Yeah.
Next.
Ed, Ron Burkhardt, we met in Omaha when you overnighted in Omaha a couple of days. And you mentioned superheat temperature. Do you have any statistic? Do you have a superheat gauge on the locomotives that you can tell where you are with the superheat?
No, the Union Pacific didn't opt for a lot of those gizmos. Other railroads did. I've been on the 3751. It has a pyrometer on it. I have our test data. The 4014 was one of the test locomotives. So I have that test data, and it confirms what the Type E superheater was designed to develop in terms of superheat temperature. And it's and when all things are working well, which they always do. I shouldn't have characterized it quite like that. But the superheat temperature is upwards of 700 plus. So you will see that, and it doesn't take very long for that superheat temperature to reach that level. Once the steam flow through the superheaters is such, and your exhaust pressure allows just that, the necessary combustion to sustain the evaporative rate. That's the rate at which the locomotive is evaporating the water, developing the power. That superheat steam, that temperature rises very rapidly. The Type E superheater, it's a good design. My intention initially was we were going to convert it to a Type A, just because it's a little bit more simplified. We also have the Type A and the 844, and over time we would benefit from having some commonality in superheater components. We did not have the luxury of the additional time needed to make that conversion, so we stayed with the Type B design, and we're making a new set of superheaters just to have them on as spare. And one of the interesting things, when you look through all the blueprints on the locomotive, you see how they cut those superheaters back. And they did that for a few reasons. The firebox temperature, burning coal, burning oil, it's extremely hot. And so they cut the superheaters back to reduce the burning effect on the return bins on that second pass unit, or that second pass element inside. So as we make these newer set of superheaters, we're going to scale them back just a little bit more. It won't impact performance. and I doubt you'd even see a reduction in superheat temperature. But it's just all part of what you learn when you're operating a big steam locomotive. The steam joints themselves and everything on the front engine is going to, over time, and as I mentioned, it doesn't take very long for those components to get extremely hot. We had, much as the Challenger would burn, we had fires on the front end of the big boy, even though that all the equipment is new and there's not a lot of trash or leaves or oil or grease. But any kind of accumulation up on that front engine near any of that piping is going to reach a temperature where it's going to catch fire. It's going to combust. That's a good question.
Okay, thank you.
Hi, Ed.
Hi.
So I was on the shop tour in 2015 when you were just starting to on 4014, and you had mentioned that using the I think you said that you used the original plans from the American locomotive as for your design. So I was kind of curious how, how that compared to altercations you had to make with that. I was also wondering about the fuel logistics, if you could kind of explain that a little bit more, because, there aren't any water tanks or along the line that would deal with that. And then the third one was the deer story on the loop. Reminded me of the old story of Governor Evans supposedly jumped in the front of the locomotive to throw a kid off the track on the Denver South Park in the Pacific back in the day. So, so anyway, yeah, if you can kind of go over that a bit.
Okay. Well, your first question was about our drawings and our blueprints.
Mm-hmm.
And we are very, very fortunate that the Union Pacific saved all of the drawings. Nearly all of them are in existence. And we're also very, very fortunate and very grateful to the Union Pacific Historical Society for very painstakingly archiving, scanning every one of those drawings. And that's why they're available to us. They're also available electronically online. We made very few alterations. The only alterations, any significant alteration, would have been like a continuous blowdown or changing the piping and making the activation of the blowdowns, simplifying that, making it so we can control that and automate it in the cab. A lot of those earlier designs were set up at the roundhouse. Once the crew got on the locomotive, they pretty much couldn't adjust much of that unless they knew where to go. So we changed that piping, and we did the same thing on the 844 so we could improve our operations.
Yeah.
So we really didn't make many adjustments. That was one of the reasons that we could put the locomotive together so quickly, because using those blueprints, using those drawings, we could take that modern drawing or the drawing and convert it into a modern CAD drawing.
Yeah.
And then create a three-dimensional model out of it and do what we need to do. If we needed to make a casting, or if we needed to, for example, on the running boards, you could draw that and you could provide that file to Puma Steel in Cheyenne, and they could take and process that steel for us and oftentimes give us same-day turnaround. And then we put the thing together. We'll make drill holes in it. We're going to weld it. We're going to continue the fabrication process. But the first step of cutting out that piece of steel or burning a bunch of holes, whatever that may be, that really simplifies that process. And it also gives us the top quality that we want.
Yeah.
It's always a difficult thing, restoring old equipment. What part do you want to be original? What part do you want to make new? And I've long ago, I've got over hey, I'd like to keep this part of the locomotive new versus I want to keep this part of the locomotive old. Parts of the boiler, there's no nostalgia with boiler. There's no nostalgia with the pressure vessel or piping. If that is corroded, if it's deteriorated or at all wasted, it must be renewed. There is no safety. There's no reason to take an old locomotive and say, well, we got the old 97 here, but you know what? we kept this part of the boiler because it's our 1897. Well, think about that 1897 or 1915 or 1927, or pick your year, pick that metallurgy and consider making it new. So when we got into that boiler, we just cut out anything that we needed to. Now, on your second question, the fuel logistics, and we've pretty well got that fine-tuned with our 844. There were a period of times over the years that we'd run out of fuel. The other locomotives that operated on UP steam ran out of fuel frequently. Some of them in a pretty significant manner, such that can affect your locomotive. Imagine a firebox temperature and all of a sudden having the fuel run out, and the firebox temperature goes from 2000 down to atmospheric air.
Yeah.
And so you want to avoid that at all costs. So we always plan a margin there. And that was kind of going back to why we have a diesel. We plan all of our operations within a very easily achievable fuel and water range. On the 844, you're pretty comfortable. You could make 280, 300, maybe a little bit more if you don't have any operating delays. The 844 with that 80-inch driver can operate at 60, 65 miles an hour. No problem. The 4014 with the 68-inch driver, now you're down to 55 miles an hour with all your stops. You've got a lot of PR stops, and you start stretching your day out. And then pretty soon you're thinking about, well, 180 to 200 miles is probably pretty comfortable with that. We've gone a little bit farther. There were times when we went 220 miles, but you've got to be really careful. You've got to stay on top of your planning, and you've got to stay on top of your execution. If you've got any delays right there, you're putting the entire operation at risk. So those are the things you think about. Did I answer your question okay?
Yeah, that's great. And can next summer, come on up and see us up in Como. So hopefully
I'd love to.
Yeah.
I love that place.
Yeah, it's fun.
Yeah.
Okay, great. Thanks a lot.
Thank you.
Hey, Ed, this is Dave Schaff.
Hi, Dave.
What I was going to do is maybe read a couple of questions that have come in on the YouTube side. And before I do that, I just remind all of our listeners that if you will mute your microphone, unless you're specifically asking a question, that'd be great. Then we don't get the occasional dog or coughing or whatever. One question is, let's see here. Let's see, 25 miles to gallon. So how much oil does it hold and how much water, and any idea of, kind of what your burn rates are, Ed?
Well, the 25 miles per gallon consumption that's an average. For example, when we were pulling the excursion train up Cajon Pass, we were working 14 pounds of back pressure. Again, we're estimating this because we don't have actual instrumentation, but after running the locomotive a period of time, it's a pretty solid estimate. Our fuel consumption on that is, pushing the low 30s. So you've got a 7,000 horsepower 884 locomotive, and we've got a 2,100 ton train. We've got two C45s behind us, and each one of those has a horsepower output of 4,500. It's a 2.2% grade. So while we're running up that hill, we're working that locomotive probably a little bit beyond 2/3 capacity, and maybe just a little bit more. And so that kind of gives you a sense of how much fuel we're burning. When we're drifting along on relatively level track, maybe anywhere from 15 or so miles per gallon, gallons per mile. And the water consumption is again, it's almost twice what the 844 is, and all the numbers just add up because of what we're talking about. Many times the other factors that are important regarding our fuel and water logistics is our bridge weight. Most of our bridges on the network are designed that can easily handle the weight of a 1940s 4884 steam locomotive. We have some structures that are older, and the safety classification on those bridges, the inspection classification on those bridges are all adequate. They can all take the weight. But what we do is we come up with an engineering margin or a safety margin, or a margin of safety is the proper way to say that. And so what we do is we want to stay within a percentage. And based on that, there's an engineering team that runs the numbers on every structure for me. And that's another detail that goes on behind the scenes. So with that in mind, we've got a maximum weight limit on the entire overall consist. It's not just the steam locomotives. The steam locomotive itself is spread out over 19 axles. Some of our limitations are the centipede tender and the 6-wheel trucks on the 2 48-foot long auxiliary water cars. So we end up reducing the weight or reducing the actual water capacity to meet that weight criteria. Oftentimes we don't, I know in advance where the structure is or structures where we need to achieve that target. If they're far enough away from our departure point in the morning, then I can factor that into our planning and it doesn't impact our overall operation for the day. If it's fairly close to our departure point in the morning, now we're leaving with less water and in some cases less fuel. And that in the end is going to limit our overall operation. This is nothing new. It's something we've done with the 844. I started doing this back in 2011. We started analyzing structures and making sure that we were meeting those weight targets and that we were handling the planning accordingly, so we wouldn't ever have a scenario where we may discover a bridge that is, you never know. It is a machine, and there are situations where you've got weakened structures from storm events or other things of that nature. Maybe a fire, something like that has weakened an old bridge. So we want to stay on top of all that engineering analysis.
Okay, I got another question for you here. Let's see. A person is asking, and here's another thing: when the people that are on the Zoom meeting get back on, and you have a question after this, do us all a favor. Just tell us who you are and where you're watching or listening from, because it's interesting to know. This question is under the 4014 cab number is 540DB. Can you comment on the firebox conversion from coal to oil?
Well, I'll just give you a brief summary because, as I mentioned at the beginning of our discussion, that is actually part of an update that we're working on. And we're going to get into some of the technical details about that. There's a lot of speculation about oil burning locomotives, particularly the big boy. Over the years, it's just interesting how there's either a legend versus fact or hyperbole that the locomotive won't work, it can't work, but it does work. So very simply put, the oil arrangement on any steam locomotive is pretty simple. And that's pretty well across the board on anything on a locomotive. Needs to be two things: very durable and simple, as few moving parts as possible. So the system itself is what we call a demand type system, meaning that we have the ability to regulate air entering the firebox, but in a pretty limited way. So whatever air entrance is required, it's brought in terms of how the locomotive needs it or the demand that the locomotive is placed on. So the greater the horsepower development, the greater the evaporative rate, the greater the exhaust pressure, the greater the exhaust pressure, the greater the pressure in the smoke box, which creates the pressure to provide that combustion air in the firebox. So it's really pretty simple. You take the gas flow, the flow that is flowing through your tube sheet, all of the surface area of the tube sheet, and you calculate percentages of that gas flow, some of it at the door, some of it around the burner, and some of it is additional combustion air strategically placed around the bottom of the fire pan to allow that burning oil to mix with all of that different combustion air coming in at different places to provide you with the right combustion. And that's the trick. We made alterations on the 844 early on to improve how tight the front end is, to line up all of the nozzles, the smokestack, and create the most efficient, what's known as a seal. So as that exhaust steam travels out of the nozzle and out the stack, it actually creates a contact area known as a seal. And that prevents that negative air pressure from drawing air in and down the stack. So it creates that required pressure. If that's not lined up just right, you will actually have small little air currents that are able to find their way back down through a path of least resistance and negate that exhaust pressure effect that you need to provide all that combustion air in the firebox. So sounds pretty complicated. It looks complicated, but when you understand the basics of what a steam locomotive is, complicated mechanisms on steam locomotives typically didn't survive much past the 1920s. You got into the 1930s and 40s, and they were really refining things. You didn't see a lot of moving parts and a lot of complexities, the coffin feed water heater, a lot of those really complicated injectors, that just wasn't it. We needed to come up with something simple. It's interesting to note that the 4014, the 4000s, 3900s did have a very complicated exhaust steam injector. So, but it works good. So did I answer your question on that, Dave?
That was one that was written in, so I'm guessing that you did.
Okay.
And
good.
then I'll ask one more, and then we'll let somebody else that's tuned in on the Zoom side get in. Jacob asks, what are you doing to the locomotives this year?
Well, that's a good question. We're really not doing a whole lot other than a few little things that we wanted to do last year. A few things that we didn't have time to do before we departed, upgrades, just minor adjustments, in making improvements. We had an issue with one of the crossheads, as you recall from our test run down to none. We had a crosshead running warm on us. And so we re-tinned and remachined that crosshead, just working through a few little things here and there, nothing significant. Adding a drain line here and changing a little route of the piping there, just going through and cleaning things up. One of the things that we are doing relating to the oil conversion is we're adding additional air at the door. So we call that overfire air, and we're adding additional several, almost 150 cubic inches of additional air at the door. Again, this is not something scientific that we really delve into. When you're around a steam locomotive, you have a sense of what it sounds like when it wants to be where it needs to be. And in my judgment, it wants more air at the door. So we're going to give it some more air at the door. And we're making, we have to physically make that arrangement bigger in order to make that happen. That's really the most significant thing that we're doing. Changing the brick arrangement, that's another thing, but I don't want to get too much into that because that's kind of where we're going to go in our next little update that we'll be putting out.
Okay. If anybody on the Zoom call has a question, now's a good time.
I was also wondering about why the grain cars were on the back of the train.
Oh, that's a very good question. Well, oftentimes when we travel with the steam locomotive, you've got that big 600-ton steam locomotive, and you've got the water cars. Each one of those represents the same weight as a conventional diesel locomotive. We'll have the diesel locomotive with us. Sometimes we will, maybe sometimes we won't. But when we get rid of the large passenger train, now we don't have a lot of train back there.
Yeah.
And so we need to have those cars for braking. And they serve, they serve the purpose for braking, but it's mainly braking in an emergency event. So in the event, because as you're operating the locomotive, it's very routine. You're coming into a location where there's a planned stop, and if you're on a descending grade, you'll use that dynamic brake on that diesel locomotive to help, retard the motion of the train, bring it to a nice easy stop. As you're making the final stop, set the air brakes and come into a nice controlled stop. That's very routine. When you're in a scenario where you've got an emergency situation, now you've got the braking effort of the entire locomotive consist, and you have to bring that to bear very quickly. And it's designed to do that. We maintain it to do it. It's very safe to use it in that manner. But what you don't have is you don't have a lot of train consist back there. And you've only got 4 or 5 passenger cars. And those disc brakes on the passenger cars by themselves are quite weak. When you get a number of them together, they're quite strong. When you get a big passenger train with all those disc brakes on there, that system is known as HSC, a high-speed control. It's a beautiful design system designed to work very well. But if you only got 3 or 4 passenger cars back there, you got to think about what's going to happen if we need to bring this entire arrangement to a stop. So we'll pick up a number of cars back there, and it doesn't take many freight cars combined together. You got a lot of brakes now, and that's just what you want.
Oh, okay. Were the grain cars full?
No.
They're
No.
empty. Okay.
Yeah. And they look good, don't they?
Yeah.
It's kind of neat to see that.
Yeah, they were all clean. That's a good thing.
Yeah.
Yeah, that was by coincidence.
Yeah.
Yeah. No, it actually
no-
it worked out. We have a partnership with so many people on the railroad, and our operating partners back on the Salina sub. They made sure we got a good set of cars, and they just happened to have those cars around. They were in Salina, and we had arranged that arrangement was in place for weeks and weeks that we were going to pick those cars up and take them back.
Oh, okay.
That's a good question.
Great. Thanks.
And they didn't have graffiti on them.
Yes.
Yeah, we wouldn't have wanted to see graffiti on the steam train. That's for sure.
Yeah.
No.
Yeah, and it happened to make the 2021 calendar. So you can see that consist is made our January calendar shot for this next year. Yeah.
Hey, if anybody doesn't have a question at the moment, I was going to, for those of you that maybe don't get our newsletter, I was going to read a little bit out of here that was written by Jim Ehrenberger, who has been around the UP for a couple of years and knows a little bit about the system. But he writes that this year, and I think specifically November, is the 60th anniversary of the Rocky Mountain Railroad Club operating the first Union Pacific 844 excursion between Cheyenne and Rawlins. And interestingly, he writes that before that, there was a special that the club had done on the Colmont branch out of Laramie back in September of '57. And I think maybe one of our board directors, officers, had got a little stinky and maybe not been the most diplomatic when he was dealing with Omaha, because I think the story Jim told me was that on this train out of Laramie, they added on about a dozen cars of stock, and these had to go just a few miles out of Laramie. And this president of the club was really ticked off at the time for having this stock cars added in there. But from what I understand, all the rail fans that were on the trip thought it was great. You know, it gave them a chance to stop and see the stock train get cut off, I guess, at a siding, and maybe see the animals unloaded. I mean, if you think about it now, it's a photo opportunity that people would, just love to have, because you can't pay for that kind of thing. But that almost got the Railroad Club on the bad side of Union Pacific for a long time. But luckily, 60 years ago, we started doing trips with the 844, and we kind of have a long history of steam connection with the railroad ever since. Does anybody else have a question for Ed that's on the Zoom call? I know there's not a lot out there. There's probably more people on YouTube. I'll read another one here, Ed, off of the YouTube. Dan asks, does 4014 use positive train control, and is it tracked remotely by the UP? I guess that's a good question. I don't know if that's something you can answer or not.
Well, we have a GPS tracker on one of our tool cars, and we're evaluating whether we will equip the 4014 and 844 with PTC. Our initial vision was that we would. From an operational standpoint, it's when I talk about the simplicity of locomotive equipment and keeping it simple, that's always a benefit to not have additional hardware or any type of mechanization on there that could cause issues. So we're evaluating that. So at this time, it does not have it. Good
Okay.
question.
Another comment from Big Deal somewhere south of here. How will you have to, will you have to deal with the PTC mandate? I think maybe you kind of answered that already. And then, of course, another question comes from more than one questioner about steam runs and excursions. I think probably all of us can imagine that we'll have to wait and see how this whole pandemic thing sort of settles down. But I'm guessing Ed or the STEAM program or the PR folks in Omaha will put out news on various social media or the website when excursions start up again. But whatever you got to say on that, Ed.
Yeah, at this time, it's just too early to even speculate on what that might be. You know, we have planning going forward, but we're not prepared to release anything until we're really able to get a sense on, as you mentioned, where everything is and how everything ends up working out.
Another person says, how does it feel, Ed, when you're actually operating the world's largest steam locomotive?
Well, it's an honor and a privilege that all of us, we don't take it for granted. You know, we think every time that we operate the locomotive, there's so much work that goes into the preparation side that all of us have spent just literally our lives working up to a point to where you would have an opportunity to do something like this. And it's a revered place that we think about that. When you're getting ready to operate, when you're getting ready to go for the day, there's so much planning and so much work leading up to that, you almost lose track of what it is you're actually doing. But frequently we comment to one another that, can you believe that we have this opportunity? And it just underscores all the more reason that we want to do it right. We want to make it all count. We want to have the best interaction with the public and give them the best opportunity to get photographs, which is, it underscores our planning, all of that. We just want to do everything right. But operating a locomotive, it's an honor and a privilege. I've operated a lot of locomotives, smaller locomotives, and working up to this locomotive, it's just that much bigger. I don't know how else to characterize it. It's a very big locomotive. You can feel every aspect of it, and you see that front engine in front of you in your peripheral vision. That's why you hang out the cab so much. There's a lot to see. And that little window you have in the front doesn't provide a lot of visibility. So you're hanging out that window, and you've got the rear two drivers of that rear engine are not that far from you, but the front engine is 85 feet away. That's the length of an auto rack.
Right.
So it's just a tremendously big locomotive. And I'll just add this one more quick story. The moment that I was given the opportunity to sit in the 4014 in California, the day that I went to visit them, to ask them if they would be willing to give it back to the Union Pacific, we spoke for a few moments, and then they offered to open the cab. So they unlocked it, and they had bars on the windows, and they took the bars off of the engineer side window. And I sat in the seat, and almost just instinctively, without even thinking, my left hand moved up and rested on the throttle as I leaned out. And I remember thinking to myself, I might even utter under my breath, this is a big locomotive. Having run the 3985, run the 844, run the 3751, the 2816, it's not a big locomotive comparatively, but I remember thinking, and not having a fearful reaction, but more of a very, very impressive, this is a big locomotive.
Oh yeah,
And
that's got to be humbling. Yeah,
it is. We
I
said that moment we pulled it out of the shop, because as I mentioned, we were looking at a month and 500 miles of break-in. Well, we got that thing out of the shop and we're focused on doing this and doing that. And then you finally sit there for a minute and you're 11 feet in the air. Your armrest is 11 feet from the top of the rail, and other trains go by and you're looking down in the cab and you're towering over the diesel locomotives, and that the width of that locomotive and that boiler hanging out, going around a curve, the back of that cab is hanging out. And we're passing a train. He's doing 40 miles an hour and it's 14 inches from your arm. you know, it's really something else.
I know now most of us have not had the chance to be up in the 4014, but there are a few big boys scattered around the country. So if you ever have a chance, for those of you out there in TV land, to sit in the cab of one, like at the 40 Museum or something, that forward window is just like a little thumbnail sliver. I can see why Ed is always hanging out the window. And speaking of cab shots, we had run one earlier, Ed, while you were talking in your program. We had a picture of you and Ted, both on the fireman's side of the big boy. And that, for those that don't know, that would have been sitting at the crossing right by the Colorado Model Railroad Museum in Greeley last November. And that was a chilly day, but we did show that picture, Ed. I don't know if you got to see it, if you've had a chance to glance at the other screen during this. I know you've been pretty busy giving us more than we can ask for. And as everybody has probably come to realize now, there's a lot more going on than what most of us understand. You know, when Ed talks about train handling and all the other little pieces that come into play, the average rail fan, or, you know, we hate to use the word foamer, but the average person really doesn't know what all's going on out there. Somebody noticed when your phone fell down earlier, Ed, we might have got a picture of your arm. Somebody wondered if you had a sling on and if there's any story there.
No, I just I had some surgery on my arm, but everything's good. Yeah, just routine maintenance. I had to go into the back shop for a little bit of work. Everything's good.
Hey, so every once in a while, I'm sure this question still comes up, and one did come in on the texted in on the YouTube side about 3985 and where it might potentially go for display. And I don't know if that's even up to you or if that goes through the PR division in Omaha.
Well, there's no plans on the 3985 other than it staying right where it's at. And it's resided in that roundhouse now for many years, and that's where it's likely to remain.
Okay, all right. Does anybody else have more questions that's live on the Zoom call?
I just have one comment. I joined the Rocky Club back in, I guess, about 1965 for the first time, and I rode the trip from Denver to Rawlins, I guess it was, and the trip back was decidedly fast. Behind the 844, it was or 8444 at the time. It was interesting.
Yeah, that's a fast locomotive. You know, back when it was in regular service, it was not considered to be irresponsible or speeding to run that locomotive fast if you needed to. In our railroad environment today, having a locomotive run 100 miles an hour is unthinkable unless you're on the Acela corridor or some passenger corridor in Europe. But that locomotive was designed to do it. It's a remarkable machine. Best locomotive in the world.
It was the speed, the mile markers. If there was no whistle posts mixed in there, they were going by at a rather rapid pace.
Yes.
And I won't say how fast because it was probably more than the speed restrictions allowed, or the timetable allowed at the time.
Yeah.
Well, Dave, we're coming up on 9 o'clock here, and the questions seem to have dwindled off. Shall we give Ed the rest of his night back? And a big thank you for coming over and talking to us tonight. We very much appreciate that.
Thanks.
Well, thank you very much. I appreciate this opportunity, and on behalf of our great crew in Cheyenne and all the wonderful, kind supporters and our colleagues on the Union Pacific Railroad, we thank you for this opportunity.
Well, we're really glad to have this long-standing relationship between UP Steam and the Rocky Mountain Railroad Club, and certainly appreciate your time. And I'm sure there'll be people clamoring for you to come back and talk to us again somewhere down the road. Hopefully, it'll be one of those times when we can have our meetings in person again. I think we're all looking forward to that.
Yes, thank you, everyone, very much. Thank you.
All right. As I said before, everybody, our next meeting is coming up the second Tuesday in December. That will also be our annual business meeting, which takes about 3 minutes. And then our presenter will be Scott Lotus from the Center for Railroad Photography and Art. And then our January show will be from Steve Barry, some Pennsylvania-centered pictures. And Stephen Peck will be our showboat for February. And I guess with that, we'll say goodnight. Thanks for putting up with the fact that my camera doesn't work all the time, and we kind of had to put together a cobbled together thing between phones and computers and whatnot. But we're doing the best we can. Thanks, everybody. Thank you, Nathan, for holding us together.
Hey, I do what I can, Dave.
Right.
Good night, all. We'll see you in December.
Thanks.